Okay, this is exercise 12.9, question 4a on bearings. In this question, we're told that Lou drove for 72 kilometres on a bearing of 51 degrees. Now, before we can put that bearing in, we'll need to put a north sign in. I've just got across there, so north, south, east, west. And Lou drove on a bearing of 51 degrees. Now, remember, bearings start from north and go clockwise, so we need to go clockwise from north roughly about 51 degrees, which would be a little bit more than halfway across there. So I'll just put that direction in there. So that's the direction roughly that Lou has travelled in. We need to put that it's 51 degrees. Of course, the bearing is 3 figures, 0, 5, 1, but when you're just drawing it on your diagram, you can just put in the 51. So I've marked that in, that Lou's travelled on a bearing of 51 degrees. And the question is, how far did she drive north? Now we can see from where Lou started that she is actually northeast. So what we'll do, we'll put those lines in. So Lou has driven across there, but that is actually northeast from where she started here. So we'll put this line down there, and that would be the distance that Lou has travelled north. So I'll just put an N there. And then I'll complete the triangle by putting this green line across here. So this is the distance along here that Lou would have travelled east. So I'll just put a little E there. Okay, and of course this is a right angle triangle, so I'll put a right angle there. We were also told that Lou drove for 72 kilometres, so I'll put that along there. So once again, Lou drove for 72 kilometres along here on a bearing of 51 degrees. How far did she travel north? So you'll find that blue length there. And how far did she travel east? You'll find that green length there. Notice we do not have a angle in the triangle. So if this angle over here is 51 degrees, then this angle down here that I'm marking here will be 90 minus 51, because between north and east along here, we have 90 degrees. So 90 minus 51 is 39 degrees. So I'll just mark that in there. So now, when you do the question, you can see that you've got your right angle drawn, you've got 39 degrees there. When you want to find north here, this distance, you can do sine. So sine 39 is n over 72, and you can solve that. And when you want to find east, this distance along here, you can do cos of 39 is e over 72, and you can solve that as well. Now, question 5 in exercise 12.9 bearings. This is question 5a. So we're told that a ship leaves port and sails 25 kilometres due east. So what we'll do, we'll just put in our little direction there with north. And our ship sails 25 kilometres due east, so it has to travel along here. I'll just put a nice line along there in green. So it's travelling along here, east, and the distance that it's travelled is 25 kilometres. So it travels from A to B. So I'll put A there and B here. So that's the first bit. A ship leaves port here and sails 25 kilometres due east from A to B. The ship then turns and sails due north to C. So I'll then, from here, we can put due north here to the point C. Now we don't know what that distance is. I'll just put a little right angle in here to show that, because if that's east and that's north, this angle in here is 90 degrees. So I'm just bringing in that right angle here now. Then we're told if the bearing of C from A. So what I'll do, I'll put a line between C and A. So if the bearing of C from A, so we need to start from A, so you can just underline that or highlight it or something like that, okay? So I'll just underline it. So we're leaving from A. So the bearing of C from A, Sorry, I just underlined the wrong from there, so I'm underlining this one here. So if the bearing of C from A, so we start from A, we've got a north sign already there from A, and the bearing is 36 degrees, so we go 36 degrees in a clockwise direction from that north sign, so I'll just put that in. So in other words, this angle in here is 36 degrees. Now it is 036, remember bearings have 3 figures, but on my diagram I can just write it as 36 degrees. So the bearing of C from A is 36 degrees. We have to find the distance BC. So I'll just mark that with an X on the diagram. So notice we have our right angle triangle. This is 25 kilometers, that's X, what we need to find, but we don't have an angle in the triangle. So again, remember that this angle here, which is 36, and this angle here in the triangle, that angle there plus 36 add up to 90. So what we need to do, we need to work out what 90 minus 36 is, and 90 minus 36 is 54 degrees. So this angle in here is 54 degrees. So now we can work out X using this triangle here in which the angle inside is 54 degrees. And here we'll use tan because tan of 54 is opposite over adjacent. So tan of 54 is X over 25, and then you can work out what X is and hence work out what the distance BC is. Now this is exercise 12.9, again, question 6A. We're told that Mooney is 73 kilometres due east of Louisville. So what we'll do, we'll just put in our starting point here. So we'll start at Louisville. So I'll just put an L for Louisville and put a north sign there so that we know where north is. Of course, we then know where south is, east and west. Now, if Mooney is 73 kilometres east of Louisville, then Mooney is along here on this east-west line. So it's along there, so I'll just mark that in green. So Mooney is along here, and so that's where Mooney is, and it's 73 kilometres along, okay? And then we're told that Newdale is due north of Mooney, so Newdale will be up there. So I'll just put in a line there to show where Newdale is. So Newdale is due north of Mooney. I'll just move this all down. And Newdale is due north of Mooney, but Newdale is also on a bearing of north 43 degrees east from Louisville. So we need a line between Louisville and Newdale, so I'll just put that in. And Newdale is north 43 degrees towards east, so this angle in here will be 43 degrees in there. And I've marked that in from Louisville. Now it's asking to find the distance between Newdale and Louisville, so we need this distance along here. You can just call that distance X. So I'll just mark that along there. We also have a right angle in there because if this is east and that's north, we have a right angle there. So I'll just mark that in as well. So we've got the right angle there. Now we look at our diagram, we have a right angle triangle. We have to find this distance over here, which is X. We know that this length down here is 73 kilometres in green, but the problem is we don't have an angle in the triangle. Because this is north up there and that's east across there, then this is a right angle here. So we can work out what this angle in the triangle will be, and it will just be 90 minus 43, which happens to be 47 degrees. So this angle inside the triangle is 47 degrees. So now we need to work out what X is, and we can use this triangle, and we will use cos, because cos of 47 is 73 on X, and then we can rearrange that equation and work out what X is, and that will give us the distance from Newdale to Louisville.